Today we're talking about quadratic equations, and what I want to emphasize today, not only will we be solving quadratic equations, but how to know which technique to use. The three main techniques are factoring, the square root property, and the quadratic formula. First of all, you recognize that you have a quadratic equation because it's a polynomial equation with the highest power on the variable being a 2. For example, over here we have 5x squared minus 10x equals 0. What I always think about when I first look at an equation is it easy to factor? Because if you can factor, it's a really quick and simple solution, and you might as well go ahead and do that. If you look at an equation and it's not simple to factor, you want to think about whether you want to use the square root property or the quadratic formula. And so there are two cases where we can very easily use the square root property. We have the case where we have no x term in the equation, like this one here, x squared plus 9 equals 11. Notice there's an x squared and there's some constants, but there's no x term like 3x or 5x. In that case, it's very easy to rewrite the equation in the form of x squared equals a number. Like in this case, we could subtract the 9 to the other side and we would have x squared must be equal to 2. And in that case, we can use the square root property. The other case where you would use the square root property is when you have something of the form a quantity squared, like a binomial squared, equal to a number. Here's an example like that. So if we see 2x plus 1 squared equals 12, there's no need to go ahead and FOIL that out to multiply 2x plus 1 times itself, because we can actually just apply the square root property and be done a lot quicker. And then the third case, when you look at a quadratic equation and you don't see an easy way to factor it, and it has an x term and it's not factored into a perfect square equals a number, then in those cases, which is all the rest of the cases, you're going to use the quadratic formula. The next problem I want to look at is solve the equation 3x squared minus 6x minus 2 equals 0. A couple things I want to mention. First of all, you can always try and use factoring, but it's optional. If you look at a polynomial and it doesn't look like it's going to factor for you quickly, then you can just move on and use the quadratic formula. I'm obviously not going to use the square root property here because we do have this x term and we don't have a quantity squared equal to a number. There is a method called completing the square where you can rearrange this to get that, but for most people, the preferred method is to use the quadratic formula. So what the quadratic formula says is if you have any quadratic equation in standard form, remember standard form just means 0 on one side, that fits the pattern ax squared plus bx plus c, then the solution would fit the formula negative b plus or minus the square root of b squared minus 4ac over 2a. You can have one solution or two solutions, and they can be real or complex. We want to write the formula down every time we're going to use it to solve a problem, and then that way we get practice so we will remember the formula better. So if you're watching the video now and you're taking notes, which I hope you are, then you should go ahead and write out the formula and make sure that the fraction bar goes all the way across and that b squared minus 4ac, which is called the discriminant, by the way, that it's covered completely by the radical. So I've decided that maybe this isn't going to factor so easily for me, so I'm going to identify a, b, and c to plug into the quadratic formula. A is the coefficient of x squared, which is 3. B is the coefficient of x, which is negative 6. And then C is going to be the constant term, which is negative 2. Notice how I included the sign here? You have to do that or you'll make a mistake. So now I'm going to plug into my formula. So x equals negative b, or the opposite of b. Since our b is negative, we change it to a positive. So we're going to plug in a 6 plus or minus the square root of b squared, so negative 6 squared, and then minus 4 times a, which is 3, times c, which is negative 2. And all of that is over 2 times a, which is 3. Okay, and now the The challenging part when you're working with the quadratic formula is to make sure you have the correct order of operations. So we're going to work always under the radical first. The exponent and the multiplication under the radical have to be performed before the addition or subtraction. We're going to have 6 plus or minus the square root of, whenever you square b, you get a positive. So this will always be a positive number, 36. And then over here we have 2 negatives. So 2 negatives being multiplied gives you a positive. So it's going to be plus. 4 times 3 times 2 is going to be 24. And this is all over 2 times 3, which is 6. Now we perform the addition under the radicals. So x equals 6 plus or minus the square root of 60 all over 6. Okay, continuing to simplify the radical, we need the prime factorization of 60. 2 goes into 60 30 times, 2 goes into 30 15 times, 2 doesn't go into 15, so the next prime number is 3. 3 goes into 15 5 times, which is also a prime. So 60 is 2 squared times 3 times 5. So we're trying to find the square root of 60, which is the square root of 2 squared times 3 times 5. Only the 2 is a perfect square, so we're going to take the square root of that. It's going to be 2, leaving behind 3 times 5, or 15. So we're going to rewrite our expression here. 6 plus or minus 2 square roots of 15 divided by 6. So far, so good. I see a lot of students get to this point and then they make an error. Don't let this happen to you. A lot of times people are in a hurry. They see the 6 and the 6. They want to cancel them out. And we can't do that. Remember, each term in the numerator in the top is being divided by 6. So yes, the 6 could divide evenly into this 6 over here, but it's not going to divide evenly into the 2. However, they have a common factor of 2. So what I am going to do is say, okay, 2 goes into 6 3 times, 2 goes into 6 3 times, 2 goes into 2 once. I can reduce everything and leave it all as one big fraction. So we have 3 plus or minus the square root of 15 over 3. Or an alternative way to write the answer would be to divide each part out. If you did it that way, you would have 6 divided by 6 is 1 plus or minus 2/6 or 1/3 the square root of 15. There's a bunch of different ways you can write your answer, and I'm going to be flexible about that. But most of the time, when we're solving quadratic equations, most of our textbooks leave the answer in this format here. I hope you found this video useful. If you did, please remember to like it.